Hi. I just realized my phone could do this. This is pretty cool. If I get good with this, then I'll be posting videos like hotcakes, okay? So, yeah. All right, anyways, the topic today, linear functions, determining if from a table of values if that function is linear. Uh, I would have also made another video on linear functions, but we'll just see how this one goes and then yeah. Okay, anyways. So, I would have made this video already. So, linear equations right here. This is one form. This is called the slope-intercept form. Okay. Y is equal to mx plus b, and this m and this b, these are constants, and the x is open, free variable. Okay. This m is called the slope, and this b is called the y-intercept. If it's making no sense right now, don't worry, I'll explain it later in class. And I don't know when the other video is going to go up, but yeah. Okay, cool. So for this topic, right, with these tables, you have to determine whether the function that the table represents is linear. And the way you do that is you check if for any two pairs, right, of points you choose, these two rows, you want to check the slope, which is m is equal to y2 minus y1 over x2 minus x1, or another way of saying that is change in y over change in x is equal to rise over. There's many ways. Okay, so delta y over delta x. Okay, I'll talk more about that later, like I said, but just watch what I'm gonna do. So I choose two rows, right? And I have to check what is the increase or decrease in x here. So here it's plus 3, and every time and when that increases by 3, the output y increases by plus 6. So looking at the above equation here, the change in y over change in x would be 6 over 3, which is equal to 2. So this tells me that the slope is 2. Now going back to this equation here, I said that this m is a constant. So if it's a constant, that means that for the other choices, it should also be fixed. Okay, so that means that 6 to 9, is it plus 3 and is it plus 6? Yes, it is. Okay, so this is, yes, it's linear. It represents a linear function. Okay, however, if I were to tweak this, okay, he's tweaking, all right, and I make this like a 15, then that means that from the the this second row to this one, right? It's still the x is increasing by 3, but then the y would be increasing by 3, and this would be not linear because it's no longer constant, right? The rate of change at this between these 2 points would be 3 over 3, which is equal to 1. No good, okay? Anyways, next table here. I wonder if this tab thing will show in the recording. All right, hopefully not. All right, so look here. Check this one. Now from here, negative 1 to 4, this is going to be plus 5, right? Oh, I'll do that one later. So here I'm choosing the top 2 rows, right? Then x increases by 5, and then the y increases by 3, okay? So that means that the rate of change is a change of y over change in x, and that's going to be 3 over y. So that's the slope, okay? And then now let me check if it's the same for wherever throughout, right? So here, these two, 4 to 9, that's plus 5, so that's a good sign. And then from negative 5 to 2, that's also plus 3, so that means that the rate of change is also 3/5, okay? But we should keep checking. Is this plus 5? Yes, it is. Is negative 2 to 1, is this plus 3? Yes, it is, so that means it's good, okay? Yeah, on the state test, when they train you for the test, they'll just say, oh, just check each one and if it's like that. But, you know, technically the numbers I could give you could be something crazy. Like let me put like another entry here. And I said like, oh, 60 here, right? I'm just making stuff up right now. All right. And then now let me check from 14 to 60, right? That change is, what is that, 46? Okay. then you would have to check, and if this y value is something so that when you have 46 over this change in y, this thing should equal 3/5. Okay, but this is a weird number. If that makes no sense, don't worry, you won't get a question like that on it. But yeah, just know that the linear function, it has to have a steady rate of change. Okay, so every time you increase by a certain amount in the x, you change that amount in the y. This could also apply for decrease too, but just be careful with the positions.